All right, we'll get started, everyone. Thank you. Kia kanui, kia korahi, kia ko whakatiki, no mai rā, koto katoa. Welcome to you all. It's my pleasure today to be presenting on how digital saves lives. My name's Dan Jurgens. I'll be chairing the session and I'm also a co-presenter. I'll be presenting on BIM and DE and how we're utilising those on site. As you can see here on screen, I've got three other co-presenters. We'll be kicking off with Caleb, who'll be talking about technologies used in the survey in the UAV space. We'll be moving over to Mike, who'll be talking about IoT or instruments labs and the really interesting tech that he's applying across the country. As I said, I'll be going into BIM and DE, and I'll be handing over to Ryan McVeigh, who'll be talking about technologies that we're using in GIS or location intelligence. And as I said before, for those that have just joined the presentation, please take note of your questions in the comment field, and I'll address that at the conclusion of our presentations. With that, I'd like to hand it over to Caleb.
Well, thank you. My name's Caleb and I've been working with drones primarily since 2014 in the survey space, and we'll see how these can help us save lives. So first of all, how do unmanned vehicles relate to digital? There's a bit going on in this chart here, but we can see from left to right, we can see the process from design right through to the construction operation of assets, and then vertically we can see how the drones fit in there at the bottom, supplying data and also supporting things that we'll look at later on in this presentation, like VR and big data, and also the embedded sensors Mike will talk about later down there too. So they start off in building the basis. So how can unmanned vehicles save lives? Well, no doubt you've all thought of that first point there about removing people from danger. It's one of the obvious ones, but they can also help us to identify hazards. They can also help with improving the quality of our designs and our construction, and also in the maintenance as well. So we'll start at the start of the process and how they can help us stay safe while we're surveying and collecting spatial information about sites. So we don't want to put our people in hazardous situations like you might see on the left there, but we've been able to apply them in situations like at Waiuta, where it's a highly contaminated site with arsenic. We're able to survey with a drone, where otherwise you need a hazmat suit to enter, work out earthwork quantities before they remediated the site. Another example, how they can operate in very extreme environments. And so we use them in Antarctica, able to keep people safe from hazards, where this could really be an issue if anyone had to be medevac, so saving lives there. Also in the transport space, we can't do it like they did in the Newmarket Viaduct years ago, but here's an example in Upper Hutt surveying the station there with the drone, able to do it without getting in that hazardous space where the trains go, but being able to get that accurate and very high resolution detail, which you wouldn't get traditionally too. So saving lives and improving the outcomes. The bottom example there is where there was a gas pipeline above a sea cave, and it's unstable cave, it's been undermined. So we're able to send in a land-based robot in this instance with a laser scanner on it, to see what the risks were to the pipeline without putting our people in that risky space. Also in hydrographic spaces, so in water, we don't have to enter these spaces. There might be a risk of drowning or other health risks in oxidation ponds, but we can use either surface boats or we can use drones with sonar on them to reach some of these really hazardous and hard to reach places. For example, they were used in the Kaikoura coastline, as we can see how difficult that would be to access in other ways. So what we've seen so far is how the unmanned vehicles are able to gather primarily spatial data about a site, and from this we can build our reality models, our terrain models, spatial information about a site, which can then feed down into the rest of the process to bring about further benefits throughout the design, construction, operations phases. So how can they improve safety in construction? Well, again, they can do so by minimising the number of people on site. And drones are being used for this, and it's sort of in the pipeline where people are developing things like the Boston Dynamics, I think it was dog there, to be able to inspect sites as well without exposing people to the hazards. And so with all the data they collect, they can help identify hazards to people on site. But they also have the ability to capture more frequent as-built data of the site, which you may not put people in there to do on such a continuous basis. And so this can help identify construction errors, and they can be resolved and improve the building safety for the future. And also having the as-built data improves or lessens any risks with maintenance work in the future as well. Now, drones are commonly used now for inspecting hazardous locations. So it means that people don't have to work at heights as often, as we see in the cell phone tower in the top center there. Or on the top right, we've got a drone that can go down underground in a manhole to inspect a collapsed main there as well. So we're having to put people in those confined spaces. So as well as protecting people in that way, the data allows more people to interact with the data, do virtual inspections of sites, and to be able to pick up more potential safety issues or maintenance issues that may not have otherwise been picked up to improve safety for everyone. And here's another example of a project we've been involved with to improve safety of hydro dams, concrete dams. So obviously a massive risk here if these sorts of structures fail. And so they have safety processes and inspections in place, but to enhance that, we've used drones to map in detail all the potential defects on that face. And so we're able to obviously remove people from having to actually inspect it by working at heights, but also get a more complete picture and spatially monitor over time to see how any of these defects are progressing, so improving safety of our dams. And in addition to just visually inspecting things, we can add other sensors to our drones. So at the moment, we've added a dry film thickness sensor to one of our drones to assist in coating inspections, so be able to inspect bridges and chimneys and tanks for the thickness of the paint and other coatings there for maintenance and safety. But we can also add other sensors as well, like that first example for soil contamination. We could have potentially measured the arsenic levels with the XRF sensor. And there's other sensors like material thickness sensors as well to improve our inspections of assets for their safety and keeping people out of those hazardous environments.
Thank you, Caleb. I'll hand the presentation over to Mike and his lovely orange hair.
Cool. Thanks, Dan. Just so everyone doesn't know me, my name is Mike Lusby, and I'm a Principal Instrumentation Engineer for WSP. And today, I'm going to be talking about sensors and how we've been using these to enhance and protect public safety and assist with rapid, informed decision-making by providing timely and accurate data. Some of the questions my team are often asked to assist with are there safety concerns on my cycling routes? Is my road and or slope moving? Are vibrations causing settlement or other structural problems? Is my damaged structure presenting further risk? How is my bridge performing with advancing age? But most importantly, how can I gather real data to help me understand a specific problem? And the great thing is, embedded sensors have been assisting us in answering these questions for the best part of a decade. Before I get into specific examples of how we view sensors, I want to introduce BART, our smart instrumented bicycle. BART was developed to measure and provide specific insights about the interactions between cars and cyclists during vehicle overtakes. And here's a snap of video we've put together to highlight BART's impressive capabilities. So BAR collected about 6,000 vehicle interactions across the Lower North Island to inform the need for a minimum cyclist passing gap law. And all of the data that BAR collects is geolocated and can be overlaid onto a map, which can really highlight what's going on within your network. So all the areas where we've got orange dots are where cyclists felt uncomfortable on the network, and you can see they sort of congregate together. But we've also used sensors for cycling safety in other ways, such as our cycle lane study. A photo of this equipment is shown on the right. WSP used sensors to determine the absolute lane position and speeds of both cyclists and cars. And this data was used to determine the effectiveness of different road marking treatments. The goal was to objectively determine which marking style maximized the safety of vehicles passing cyclists by naturally increasing passing distance and slowing speed. And another great example of how we utilize sensors is on the next slide, which is determining if slopes are stable. At this location, a large slip left the road in a rather precarious state. You can see it's actually overhanging the land. This location was well beyond any power or communications infrastructure, and WSP needed to find a solution that could help protect the working people on site. We utilized a satellite communication system in combination with our sensors, which allowed us to operate an on-site alarm in real time should conditions of the slope change, and also allow us to collect long-term trend data. The plots on the right show the fidelity of the data that we were collecting from just one of the sensor types installed. WSP has used sensors for this purpose across the country, ensuring the safety of some of our most at-risk slopes. Settlement also affects structures, and one of the primary mechanisms is vibration, usually the result of nearby traffic or works. Vibration presents risks to structural integrity, but we can assist in managing these risks with real-time sensing and notification. On the right is a photo of a vulnerable structure, which for approximately the past year has been subjected to intense ground vibration works from nearby construction. WSP utilized both vibration and settlement sensors, which enabled a rapid response to stop work. The output from these sensors were included into the construction vibration management plan, and a long-term view of the data is shown on the right, which shows the change in orientation of the structure over the past year. The data there is indicating that the structure has been kept safe during the works. The sensors enabled the project team to rapidly change construction methodology when it was detected that it was presenting a greater than expected risk to the structure. Another area where WSP used sensors extensively is the ongoing management of assets such as bridges, and it can be separated into two categories: proof load testing and remote monitoring. Proof load testing is where we install precision sensors onto a structure to measure the structural response and then present a known load. This data allows our structural engineers to interrogate the performance of a structure as a snapshot in time. And proof loading can be a lot of fun, as highlighted in the following video. The flip side of proof loading is known as remote monitoring. And this is where we install the same precision sensors, but with a focus on long-term trends and data collection. We consistently sample the structure and present this data to our structural engineers via an online dashboard in the performance metrics that they are interested in. This allows the identification of changing structural response over long periods from the comfort of the office, all while keeping a constant electronic eye on the structures so we can respond to any unexpected events rapidly, such as floods. And the next slide, I'm going to talk about a specific structure that was flood damaged. We can often use our sensors to help determine the risk posed by damaged structures. The photo on the right here shows a structure that was damaged in a large flood event. In order to retain use of the structure, WSP fitted a number of sensors to assist with managing the risk, and all of this data was populated to an online dashboard. What the sensors ended up telling us is that during a further flood event in early 2022, the structure experienced a failure, and therefore the risk to the public increased significantly. And as a result, WSP was able to identify this remotely and close the structure to ensure that the public remains safe. So what I've covered in the short presentation today is a range of scenarios where sensors have played a key role in protecting public safety. But there are some challenges to the effective use of these sensors. I've put a few of these on the slide, but it all boils down to the what, why, where, and how we place these sensors to collect precise, accurate, and timely data. But this needs context. and it needs storytelling to convert the data into relevant information. And this is a science, and that science is called instrumentation engineering.
Thank you, Mike. Excellent presentation. I'm going to do the next section. So I'll be talking for about 5-6 minutes around mixed reality. By mixed reality, we're talking specifically about augmented and virtual reality devices. The project I'm going to be talking through specifically is a City Rail Link project. This is about how digital can save lives on this, which is the New Zealand's largest infrastructure project ever undertaken. What you're looking at here on the screen is obviously downtown Auckland, and we're specifically talking about this orange little line snaking through the CBD. This is the new works. So this is cut and cover, tunnel boring machine, couple new train stations, and major redevelopments of Britomart and Mount Eden Station. One of the important parts about this project is that we created what's called a common data environment. All that simply means is there's a collection of digital models and data that are collectively housed in an environment that can talk and push and pull to each other. So information and models are used many times. So we're not creating models and data specifically for safety exercises or site-built analysis. These are the same design models that have been repurposed in different circumstances. And today we'll be talking specifically around driver sighting videos, evacuation trials, and virtual reality and safety. And by augmented and virtual reality, I'm talking about virtual as the Vive headsets, where you literally put them on your face like a mask. Everything is virtual. Where augmented is what you can hear, we can bring your own device and attach it to this device, which has a very accurate GPS render on the top. And so it's augmenting what you can see through the camera in a digital model. That augmented example in a bit more detail, as you can see here, if you're not familiar with the site, this is Mount Eden. And there's a massive retaining structure that's going in here, prepping for the tunnel boring machine to make its way down towards Britomart. AR was used extensively, or augmented reality was used extensively, so you can walk around the site and hold the device in front of you and kind of look at it and point to it and talk to it. It's a very different experience to having a headset on your face. Another example here I'm going to talk about is with site signals assessments. So at the bottom of the screen is a point cloud scan using some of the techniques that Caleb was talking about previously. So this is a digital point cloud of that area. And then what you're looking at here is a blue sphere is the driver's sight or driver's eye line in the train. And what we're looking for is, can you see a signal down the track whilst the construction is live? You've got this temporary boardings up. So this is a combination of a digital model or BIM model. It's also got the laser scanning here and then augmenting over this reality. So what we can see is we discovered that actually through this quick exercise, these bollards would actually obstruct the view. And so these adjustments would be able to be made, and this reduces a substantial amount of time in the redesign. But also historically, they literally do it by walking down a train line. So obviously it's a hell of a lot more safe to do this in a virtual environment. Here we go. Try it again. So again, using driver awareness videos. So this is again the same context, the same space, the live construction on the right-hand side. So this is using the virtual reality headsets, taking drivers through what the new environment will look like prior to them driving down this live network. So we're able to assess that and train them and coach them prior to actually get into a train and experience this for the first time in the field. The example what we're showing here in rail design is this is again talking about sighting video indicators. And so we used the 3D models and accurate luminance of materials for doing assessments of the signaling. So what they wanted to assess in this circumstance, would the green signs and the red signs, or changing the exits to green signs away from the blue signs, which is traditional for Kiwi Rail, would that cause any confusion? What actually also happened with this, during this VR exercise, the drivers actually went, oh, hold on, will this breaker signal here potentially be confused for the lines around the actual exit space? We wouldn't have even considered that unless we're using these type of environments. It was a really good exercise. But what we discovered that through this process and assessing that was an interesting observation, but the assessment realized that that wasn't actually going to be a source of confusion or a source of problems, so we proceeded. But again, this is an immersive environment to pre-assess issues before site is broken on ground. Again, what we're talking about here, so we're talking about this live digital environment. So we've got all the models across the entire network, including machinery. So this is the tunnel boring machine, very complicated, condensed environment. You'll see some more videos of that soon. So again, using VR, this was used extensively to familiarize operators with the space prior to going down into the tunnels. More than just getting familiar with the tunnel boring machine, what we have here is exercises to simulate various scenarios. In this circumstance, we're going to show you a quick video to simulate a fire situation. And the goal of this exercise, it's essentially a game, is to find and get to the refuse chamber. So this is what it looks like if you're wearing the kit. So you're in the VR kit, you're looking around the TV. Because you can imagine what this would be like in an emergency situation. This needs to be second nature. So they know inherently how to get to this location in the safety space, because it could be pretty intense environment if there was some sort of emergency scenario. Here is another circumstance of a similar sort of context. So instead of being in a tunnel boring machine, we're actually down the other end of the tunnel with some of the other equipment. And again, this is a scenario that we put the team through to familiarize themselves with the procedures and to go through and play the game. And essentially, if they get it wrong or get lost, it's game over, which is actually still really helpful. And then we'll repeat the exercise and coach them until it's second nature. Fast forward a bit long here. Those goggles always amuse me. I always think of the Minions. So you go upstairs, but simple things like this, making sure that people remember to check in and check out. If that has been missed, that people don't go looking for people that aren't actually there. And the exercise ends once you get out to site and you're at your evacuation location, waiting for the emergency responders. The final video I'll show you before handing over to Ryan, this is about validating our safety controls, and this time we're talking about it from the public experience. So this is to identify any operational improvements or support any further training. And what's interesting with this is we actually record and watch people and see what they do. We've done this in other circumstances with other simulators like driving simulations for motorway networks. But in this circumstance, we push the public through and see what they do. And the intention is to improve safety by any way we can from those observations. So same scenario, this chap is in the train, a fire's gone off. What are you going to do? The sign is showing, okay, to the left, we can see a little bit closer. And this is here we're putting into smoke effects, so it's starting to get a bit darker. So is he going to go to the left, to the further distance, or to the closer distance? In this circumstance, this person decided to go left for whatever reason and walk towards the fire, which is an interesting observation. But what's more important is when they turn around, I'm just fast forwarding a little bit here, is actually what happens then. And so then they've followed along and they can see the accurate luminance levels and what we'd expect from the smoke to find their way to the emergency exit. So in this circumstance, with the examples I've shown you, we're saving lives predominantly by rehearsing worst case scenarios, and that we know with confidence that our designs work in an emergency. With that, I'll hand you over to Ryan, who is going to go for the last part of the presentation on GIS or location intelligence. Over to you, Ryan.
Yeah, thanks, Dan. Hey, everyone. My name is Ryan McVeigh, and I am the Digital Solutions Advisory Manager at WSP. And through this role and through my previous role as a lead of GIS teams and location intelligence teams, I've seen a lot of involvement lately into digital twins and the extension of the GIS platform to provide this wider real view of the real world. Next slide, Dan. So I'm going to focus on that extension of that GIS platform and into the concept of digital twins. And you can imagine how having a digital replication of a city or a group of assets has a lot of beneficial implications to how we perceive safety and how we react to implementing safety procedures within that environment. But today I'm going to be looking specifically into how we can leverage these platforms to build safer cities and to enable emergency services to be quicker acting and to be better prepared for emergency scenarios. Now, digital twins themselves can mean a lot of things, but for the context of this purpose and the constant context of our safety conversation, I want it to be understood that the main goal of a digital twin, if we're going to be using them for these purposes, is to ensure that data can go in and out. So if you think about the data that Caleb's presented in his reality capture, all the sensor information that comes from mic sensors, these plethora of models that come through for our design and for our presentation tools that Dan showed, if we can have a common method to get data and that information into these platforms, and as well as to pull them out for other purposes, then what we've created is a replication of that area or that space, which we would call a digital twin. And if we're going to be considering the wider safety of things, we need to understand how those things relate to each other in a spatial way. So what you see on screen now is the digital twin that has been implemented by Build Media for Wellington City Council. Now, what you're seeing here, this might look like reality, but what it is a model that's built from reality capture and from procedural generation from a number of tools. And beyond that visualization, we have data that has been put in place and overlaid on top of the platform. And we can utilize this to better plan our cities to be safer cities. For example, whether we want to put up a new building or a new road or a new park, we can immediately visualize how that, what kind of lighting implications are involved. Have we created blind spots? Do we need to make sure that this is properly illuminated? Is it in an area of inundation or risk to slips? This can be done preemptively But if we can build this on top of a scenario planning platform like this, then we can be much more informed into that design process. So allowing that scenario view of this really does enhance the safety that we can provide into those designs. If we look into the sensor space, one of these layers that we can bring on board into the digital twin that we can represent either on that reality mesh itself or in a number of different dashboards are real live sensor information. So what you're seeing here is a sensor that has been placed somewhere in a city that is monitoring a stream. It's monitoring the temperature, it's monitoring O2, and it's monitoring height. This information can be looked at as trends, as Mike has shown, but it also can be used to inform live information of what is happening on that stream. So it can be reacted to immediately. For example, if the stream height changes significantly in a short amount of time, this can be indicated on the screen. We can ping off emails or text messages off to people that there may be an issue happening with the stream. There may be some sort of inundation, some sort of break in a bank that needs to be reviewed or attended to. With the O2 changing, that means there could be a dump that has been happened somewhere in that stream, and we can react to that before someone may be interacting with the stream or close down beaches or do something to ensure that people remain safe based off that live information in the digital twin. If we take it along to our emergency services, you can probably think of many different ways how this would provide that value to them. What you're seeing here is a recently deployed solution for the emergency services with fire and emergency, where these tablets are representing a digital space, a digital mapping space right inside the cab of the vehicle. So instead of the emergency service personnel showing up to a job and having to do a complete assessment of the risks at the job, they're presented with a ton of information, whether it be the best way to the site, road closures, where the closest hydrants are, where the closest catch pits are, all kinds of information that will allow them to react to that incident a lot more efficiently. And on the other side of that, all that information that comes in during that job, what you're seeing here is, it might be familiar to some of you, this is the fire, a reality capture after the fire that had happened in the, in the Sky City Convention Center a couple years ago. That information that was captured during the job can now be built into the digital twin. So when we're doing a cleanup exercise, we can be assessing information around where things happened during that event and making better decisions on how to react to the smoke damage, how to ensure that there's no contamination, or how to best clean up the contamination to keep the people who have to continue to use that city safe from the risk that had happened earlier.
Might help if I unmute myself. Thank you, Ryan. Thank you, everyone else. So with that, just to wrap up the last key takeaway messages, then we'll open it up to Q&A. So digital, as you can see, can keep people away from danger through remote sensoring, improve safety of infrastructure through the monitoring, and enable the evidence-based decision-making. We can have safe cities by design. As you saw in the CRL example, our digital data and models are all cross-referenced, so they're repurposed many times. We can do site simulation and emergency procedure simulation, so we know our designs work in emergency, and we're able to rapidly respond from real-time data. So with that, our presentation is concluded, and I'll open it up to Q&A. Do we have any questions in the dialogue box at the moment? Let's have a look. Okay, so let's see the first one. So yes, thank you, Laura. That's an awesome link to that live presentation or the actual demonstration of the VR kit. That's a lot of fun, so I do recommend that. Yes, it will be recorded. First question we can see down here. How do you manage safety when humans interact with unmanned robots or drones? Do you always have a human piloting these, as humans can be unpredictable? I'll throw that one over to you, Caleb. It seems to be in your space.
Yeah, it's a really good question. So I guess in most people's experience so far, using drones, they are piloted by people, or at least if they are autonomous, then there is a pilot there nearby to keep an eye on things. I think the scenarios with Boston Dynamics dog and those kind of things, being totally autonomous, are kind of where it's heading. And so that's some of the things that those tech companies are working through. But some of those aren't quite there yet. And so I think at the moment they are at least supervised by people for those reasons.
I actually missed a couple more questions further up. And if anyone else can think of some questions as we're going along, please drop in there. So question aimed at you, Mike. Monitoring on a live work site, how are people on site alerted to potential dangers?
Yeah, that's also a great question. We've used a variety of mechanisms from emailing and text messaging and phone calls. But depending on the severity of the situation, we have also used on-site sort of alarms or klaxons to make it abundantly clear that there's a safety issue.
And you also get into the space of wearables, right? So construction staff are wearing wearables that can be notified automatically if they're entering an area with a safety issue or something has actually occurred. So it's pretty interesting tech. Next question I can see, can the emergency scenarios be run on desktop screen or other devices without VR technology? So it's more accessible, says, say, as a web page app. So I'll throw it to you in a second, Ryan, to add a bit of a location intelligence spin on that. But yeah, very much so. So the VR kit is used for training predominantly. And the AR kit is more used on site when you're wanting to hold something up and talk to it, as opposed to being in an often tethered virtual environment. But yes, it can be on, as we just touched with Mike, they could be notified by wearables, or actually I'll throw this question to our location intelligence expert, is how we could potentially map that and dashboard that in other situations.
Yeah, it is a good question, and I think it's there's definitely two different purposes to the method of consumption, the media that you use for them. But when it comes down to the data, that's the value of getting these all into one place, is that you can disseminate for the different purposes. But to answer the question, yes, definitely. The experience might be different, and it'll likely be built different to accommodate the way that you interact using a browser versus the way that you would during a VR experience. But yes, yeah, you can definitely port these one way or another into a browser environment to showcase.
Excellent. I think we actually got through the questions. Is there any other ones that I may have missed? I don't think so. And I think in this circumstance, we don't open it up to the floor for microphones. So if there's no more questions, then we may call it a couple of minutes early and give you back a few minutes of your day. I'll just pause for a second, see if there's any more questions coming through. Okie dokie, looks like we're good. So thank you for your time. It was a bit of a fast pace, fire hydrant of information, but I hope that triggered lots of thoughts and lots of thoughts to process later. At the start of the presentation, you'll have seen our email addresses. We will be sharing this presentation and recording to all attendees once it's all been processed. So please do not hesitate to reach out to any of us if you'd like to discuss anything further. And no, Alan, we're not doing YMCA. It does look like it. All right, everyone. Really appreciate your time. Thank you. And we're going to call the meeting to close.